Hi, I'm Linwood Fields, your green instructor. Today we're going to get started with Lecture 2 in 5th grade green math. Lecture 2 is on the place value system. We want to understand place value and know our place value system. We want to know how to write numbers in both standard form and expanded form. We should be able to recognize powers of 10 patterns. We should know basic place value facts. We should understand how to compare any two numbers. We should recognize leading zeros in a number and trailing zeros. We should know what a solar collector is. Now, knowing what a solar collector is not part of the Common Core standards for 5th grade math, but it is related to the green the word green in the title of the textbook. Place value refers to how much a digit is worth because of the digit's location in a number. Stated another way, place value is the value of a digit based on the digit's location in a number. Now let's not get the different places in a number mixed up with place value. Place value is associated with a digit. Remember the digits 0 through 9. Where we put those digits determines the value of the digit. The place of a digit, the place is always worth the same amount, but where we place the digit in a number determines that digit's worth. Place value allows the student to quickly look at two numbers and determine which one is the largest. And our place value system is the decimal system. Each place or location in the decimal system differs from the other places by a power of 10. For example, they differ by a factor of 10, 100, and 1,000, depending on which two places we're concerned with. Let's show place value on a calculator or electronic adding machine. The number, let's see, this is 123,456.789 is shown on this calculator. It's a 9-digit decimal number written in standard form. So it's a decimal number because we have this decimal point right here. And we see that we have 9 separate symbols or 9 separate digits. And we're interested in what, for now, what is the place of each digit. So now this title really should have been showing place on a calculator. The digits to the left of the decimal point represent whole number parts. So the digits 1 through 6 represent whole number parts. And their places are shown in the table on the next slide. So again, we're really going to start out by focusing on the location within a number, and then we're going to move to place value. Okay, now this slide is very busy, so let's pay attention and not try to understand everything on the slide at once. So here we have the same number on the calculator that we had in the previous slide. So let's go to column number 1 in this table. So remember, the digits 1 through 6 are the whole number digits because they're to the left of the decimal point. So digit 6 is in the ones place. So right here, 6 is in the ones place. The digit 5 is in the tens place. The digit 4 is in the hundreds place. The digit 3 is in the thousands place. The digit 2 is in the 10,000s place. The digit 1 is in the 100,000s place. Now let's go over to the last column here, the value of the power of 10 notation. So let's not worry about the value in terms of powers of 10, but let's just understand that the ones place is worth 1. The tens place is worth 10. The hundreds place is worth 100. The thousands place is worth 1,000. The 10,000s place is worth 10,000. The 100,000s place is worth 100,000. Now what we want to do is let's relate the value of the different places to a power of 10 notation. So in this column here, we have a 10 written down for each place, for each position. The thing that's different is the power or the exponent. So this 0 is a power or exponent. So in the ones place, 1 is the same as 10 to the power 0, because any number written to power 0 is equal to 1. For example, 8 to power 0 is equal to 1. 1 to power 0 is equal to 1. So 10 to power 0 is equal to 1. Okay, in the tens place, the value of the tens place is 10, or we should say the worth of the tens place is 10. So how do we write that as the power of 10? We write it as 10 with a power of 1, or 10 with an exponent of 1. Notice here, 1 is the same thing as we write down a 1 with 0 zeros. So there's no zeros after the 1. 10 is we write down a 1 and we add 1 0. So to easily know how to represent 10 using the power 10 notation, the first thing you do is write down a 1. Well, excuse me, the first thing you do is write down a let me go back here. Okay, to understand how to write 1 using the power 10 notation, we simply count the number of zeros, and the number of zeros would be the exponent. Here with a 1, there are no zeros or 0 zeros, so we put a 0 for the exponent. For 10, there is 1 0, so the exponent is 1, 10 to the power 1. For the hundreds place, 100 has 2 zeros, so we write down 10 with an exponent of 2, or a power of 2. 1,000 has 3 zeros, so to represent 1,000 using power of 10 notation, we write down a 10 and put a 3 as the exponent, or 3 as the power, because 3 zeros are in 1,000. For 10,000, we have 4 zeros. 1, 2, 3, 4. So that means we put a 4 for the exponent. 10 to the power 4. For 100,000, for the 100,000s place, we have 1, 2, 3, 4, 5 zeros. So the power or the exponent would be 5, 10 to the power 5. I don't think I had my laser pointer turned on when I did 1 and 10. So for 1, we have 0 or no zeros. So for the power of 10 notation, we write the 10 with the exponent of 0. For the tens place, we have 1, 0. So to write it using the power of 10 notation, we put a 1 for the power or a 1 for the exponent, 10 to the power 1. Now notice 10 to the power 1 means 10 written down one time. 10 to the power 2 means 10 times 10, which is 100. 10 to the power 3 means 10 times 10 times 10. 10 written down 3 times, which is 1,000. 10 to the power 4 means 10 written down 4 times. 10 times 10 times 10 times 10, which is 10,000. So what we're supposed to be learning here is that the ones place is always worth 1. The tens place is always worth 10. The hundreds place is always worth 100. The thousands place is always worth 1,000. The 10,000s place is always worth 10,000. The 100,000s place is always worth 100,000. Now, what digit we have in the different places determines the worth or the place value of that digit. So here, the 6 is in the ones place. So the 6 has a worth of 6. In this number here, 5 is in the tens place. So 5 has a value of, or a worth of 5 times 10, which is equal to 50. Now, had we put the 5 in the hundreds place, the 5 would have a value of 5 times 100, which is 500. So we see that the 5's value depends on what position is at. If it's in the tens place, it has a value of 50. If the 5 is in the 100s place, it has a value of 500. So that's what we mean by place value. The value of a digit depends on where it's located in a number. Now, what's the value of the 4 here? So what's the value of the 4? Because the 4 is in the hundreds place, 4 times 100 is 400. So 4 has a value of 400 in this number here. What's the value of the 2 in this number? Where the 2 is in the 10,000s place, 2 times 10,000 is 20,000. So the 2 has a value of 20,000 in this number. Okay, these 3 digits here are to the right of the decimal point, and they represent number parts less than 1. The 7, 8, and the 9, they are again to the right of this decimal point and represent number parts less than 1. Their places are shown in the table below. The 7 is in the tenths place. The 8 is in the hundredths place. The 9 is in the thousandths place. So let's make sure we understand that there's a difference between hundred and hundredths. So this is hundredth with a TH, not hundred, but hundredth, which is much smaller than 100. A thousandth with the TH is much less than 1,000. what is the worth of the tenths place? So let's go over here to the worth column. The tenths place is worth 0.1. The hundredths place is worth 0.01. The thousandths place is worth 0.001, which is smaller than the hundredths place, which is 0.01, which is smaller than the tenths place. So of all these places, the tenths is the largest of these three. 0.1 is larger than 0.01, which is larger than 0.001. So let's go from the value of each one of these places to the power of 10 notation. So we all have the number 10, but this time we write negative exponents or negative powers. 0.1 is the same as 10 to the power minus 1. 0.01 is the same as 10 to the power minus 2. So 0.001 is 10 to the power minus 3. So notice that 10 to the power minus 1 is larger than 10 to the power minus 2. 10 to the power minus 2 is larger than 10 to the power minus 3. Now, when we get to the fractions chapter, we will understand more of what this means, but rather than wait until we get to that chapter, let me just go ahead and try to make it clear to you what 0.1 actually means. So 0.1 means 1/10. 1 over 10 is 1/10. 1/10. So how much is 1/10? Up here, we are saying that all of these digits represent parts that are less than 1. So obviously 1/10 must be smaller than 1. So let me try to make this clear. So what I'm going to do is draw a rectangle and try to divide the rectangle up into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now they're supposed to all be the same size, but I haven't done that. But imagine that they are the same size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I got just one hole here, one whole rectangle, but I've divided it up into 10 parts. Now if I was to go in here and select just one of the 10 parts, let me finish coloring it in. This is the same as 1/10. 1/10. Obviously, 1/10 is less than 1 because this is the whole rectangle, but 1/10 is just a piece of the rectangle. So obviously, 1/10 is less than 1. So let's go and hopefully we can appreciate the value that the 7 here means 7/10. 7 out of 10. So to represent 7/10, I go and select 7 of the pieces, 1, 2, 3, 4, 5, 6, 7, and color or fill in all 7 pieces. So bear with me here while I fill in all 7 pieces. Almost finished. Be patient. It's a good thing to be patient. Okay, let's say that is good enough. So 7 pieces have been filled in. 7 out of 10 is equal to 0.7. So forget about the 8 and the 9. Assume that those are 0 right now. So 0.7 is the same thing as 0.700. These two zeros are trailing zeros. They don't contribute anything to the worth of this number. This is a leading zero. It doesn't contribute anything either because 0 is nothing. That's a leading zero. And these are trailing zeros. None of them contribute to increasing the value of this number here. So 0.700 is equal to 0.7. We may want to write it as 0.700 when we're doing comparisons. Or, okay, so hopefully you understand that 1/10 is less than a whole. 1/10 is 1 out of 10. Now, this place here has a worth of 1/10. By putting a 7 here, that gives the 7 a place value of 7/10 or 0.7. So again, the place value refers to a number's worth because of where it's at. So putting the 7 right here, the 7 is worth 7/10, 7 out of 10. Okay, let's go over to the hundredths place, and let me try to give you an idea of what 100th is. So again, I'm going to draw my rectangle, or let me see if I can draw a square. Make it out. Oh, that's terrible. Let me start over. And let me draw a better square. That is somewhat of a square. And let's divide it up into 100 parts. Now, I'm not going to sit here and divide it up into 100 parts, but just try to imagine that I have divided it up into 100 equal parts. Okay, so if I was to select just one of these 100 parts, that is what 100th is equal to. 1 out of 100. Select 1 out of 100. That's equal to 0.01, 100th. So obviously, if this is the whole square, and this right here represents just 100th, obviously 100th is less than 1. Again, these digits represent parts that are less than 1. So that's 100th. Now the value of this 8 here in the 100th place means that this 8 has a value of 8. Oops. It has a value of 8 out of 100, which is equal to 0.08. And over here, what does that look like? I need to select 7 more pieces. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've selected 8 pieces. 8 out of our imaginary 100 pieces. So this 8 has a place value in this number of 0.08 or 800. And I can do the same thing for 1,000. Thousandth means I select 1 out of 1,000 pieces. And obviously that's less than 1. So let me go ahead and erase all of this. Okay, place value facts. Every place differs from its 2 adjacent places by a factor of 10. For example, the tens place has the hundreds place to its left and the ones place to its right. So let me write down a number here. Write down the number 9,422. So this is the hundred, this is the thousands place, this is the hundreds place, this is the tens place, and this is the ones place. So what we're saying here is the tens place has the hundreds place to its left and the ones place to its right. So the ones place, this is the tens place, and this is the hundreds place. And what we're saying is each place value differs by a power of 10. So 100 is 10 times 10. When I go from left to right, that's the same as multiplying by 10. When I go from right to left, going in this direction, that's the same as dividing by 10 because 1's place, 1 is 10 times smaller than 10. So anytime I'm going from left to right, I'm increasing by a factor of 10. So if I go from the ones place to the hundreds place, that is 100 times. So a hundreds place is 100 times the ones place. The thousands place is 10 times the hundred place. If I go from the tens place to the thousands place, that's a factor of 100. Now again, when I go from left to right, I'm dividing by 10. When I go from the thousands place to the hundreds place, that is 10 times smaller because 100 is 1,000 divided by 10. When I go from the hundreds place to the tens place, that's a division of 10 because 100 divided by 10 is 10. When I go from the hundreds place to the ones place, that's a division of 100. 100 divided by 100 is 1. So the point is, anytime I move from left to right, I'm dividing by a power of 10. Whenever I move from right to left, I'm multiplying by a power of 10. Let's examine the number 35 in detail. First, notice of all that 35 is in standard form. And all we've seen so far is numbers written in standard form. So we're going to look at the number 35 in expanded form. The number 35 can be broken down into 2 parts because it has 2 digits. It has a 3 in the tens place and a 5 in the ones place. So we're going to represent it. We can expand it into a number that has two parts because it's got two digits. Remember, place value is the value of a digit based on the digit's location in a number. So this 5 here, because it's in the ones place, has a value equal to 5 times 1 is equal to 5. And because this 3 is in the tens place, it has a value equal to 3 times 10, which is equal to 30. Now, a 3 in the tens place means that this part of the number really equals to what I wrote on the previous slide. 3 times 10 to the power 1. Remember, 10 to the power 1 or anything raised to the power 1 is equal to that number. So 3 times 10 to the power 1 is the same as 3 times 10, which is 30. Again, like I said on the previous slide, we say that the place value of a 3 in the tens place is 30. A 5 in the ones place means that this part of the number is equal to 5 times 10 to the power 0. Remember, any number raised to 0 is 1. So 5 times 10 to the power 0 is equal to 5 times 1, which is 5. We say that the place value of a 5 in the ones place is 5. The place value of a 5 in the tens place would have been 50. The place value of a 5 in the hundreds place would be 500. So the number 35 broken down into its two components, or into its two parts, looks like the following. 3 times 10 to the power 1 takes care of the 3's worth, and 5 times 10 to the power 0 takes care of the 5's worth, because it takes care of the 5. So 3 times 10 to the power 1 is the same as 3 times 10 to the power, 3 times 10 to the power 1 is the same thing as 3 times 10, and 5 times 10 to the power 0 is the same as 5 times 1. So we got 30 plus 5 is 35. So we have written the 35 into its expanded equivalent, this right here or this notation. So this and this are called the expanded form of the number 35. So it has 2 parts because it's got 2 digits. Now let's expand a decimal number. This time we're going to expand the decimal number 1.206. Notice that this number has 4 digits, 1, 2, 3, 4. Therefore, it can be broken down into 4 parts. The 1 in the ones place, a 2 in the tens place, a 0 in the hundreds place, and a 6 in the thousandths place. So how do we represent this number in expanded form? We always start to the left. The 1 is the largest place. 1 is represented as what? 1 times 10 to the power 0. Remember, 10 times 10 to the power 0 is 1. So that's the same as 1 times 1. 2 times 10 to the power minus 1. Remember, 10 to the power minus 1 is the same thing as 1/10. So the 2 is represented as 0.2. What about this 0 here? The 0 here is in the hundredths place. Hundredths place is 10 to the power minus 2, which is the same as 0.01. So 0 times anything is 0. And what about the 6 here? The 6 is in the thousandths place, which is equal to what? 10 to the power minus 3, which is equal to what? 0.001. 6 times 0.001 is 6,000, 0.006. So the place value of a 1 in the ones place is 1. The place value of a 2 in the tens place is 0.2. The place value of 0 in any place is 0. The place value of a 6 in the thousandths place is 0.006. So the fifth grader should be able to follow these patterns. 1 times 0.1 is 0.1. 2 times 0.1 is 0.2. 3 times 0.1 is 0.3, and so on. 1 times 0.01 is 0.01. 2 times 0.01 is 0.02. 3 times 0.01 is 0.03, and so on. So the fifth grader should be able to follow these patterns. So, for example, 3 times 0.001 is 0.003. 2 times 0.001 is 0.002. Now, when we compare two numbers, knowing the worth of the places is handy, comes in handy. Here is a recipe for comparing two numbers. Step 1, look at the largest place of both numbers. The number with the largest place is the larger of the two numbers. If the numbers have the same largest place, then go to step 2. The number with the largest digit at the second largest place is the largest number. If the two numbers have the same digit at the second largest place, go to step 3. Okay, in step 3, go to the next place to the right in the two numbers and compare those digits. The number with the largest digit at this next largest place is the largest number. So we repeat step 3 until the digits are different. If none of the digits are different, then that means that the two numbers are equal. So let's go ahead and do some examples. Let's compare 301 with 299 to see which number is largest. Now, the first step is we go to the largest place for both numbers. The largest place in this number is the hundredths place. There's a 3 here. The largest place in this number is the hundredths place, which is a 2. And we have a 2 in the hundredths place. Because 3 is larger than 2, then 301 is larger than 299, because 3 is larger than 2. Which number is larger, 2,901 or 2,933? So again, using our recipe from the previous slide, both of these numbers have the same digit in the thousands place. The thousands place is the largest place in both numbers. Because the digits are the same, we go to the right, the next largest location. We go to the hundredths place. This number has a 9 in the hundredths place. This number has a 9 in the hundredths place. So we got to go to step number 3. We got to go to the next largest place, which is the tens place. This number has a 0 in the tens place. This number has a 3 in the tens place. Because 3 is larger than 0, 2,933 is larger than 2,901. Which number is larger, 0.006 or 0.1? This example brings up a good point that needs to be made about decimal numbers. The first two zeros right here, the first two zeros to the right of the decimal point in this number are leading zeros, and they only serve as placeholders. So these zeros do not contribute any value to this number. So the largest place in this number is the thousandths place. The largest place in this number is the tenths place. Because the tenths place is larger than the thousandths place, then 0.1 or 1/10 is larger than 6 thousandths. Now, sometimes when we comparing numbers, it helps to make the number of digits the same. For example, we could write down 0.006 and rewrite 1/10 as 0.100. So we have the same number of digits in both numbers. So obviously 0 and 0 in the ones location, we can't determine which number is larger. Now, if we look at the tenths location, there's a 0 in this number here in the tenths location, but down here, there's a 1 in the tenths location. Because 1 is larger than 0, then that means that 1/10 has to be larger than 0.006. Okay, let me erase this. This time, which number is larger, 1.29 or 0.99? The largest place in 1.29 is the ones place. The largest place in 0.99 is the tenths place. The 0 in 0.99 is what's called a leading 0, and it is a placeholder. Since the ones place in this number is larger than the tenths place, 1.29 is larger than 0.99 because the largest place in this number is the tenths place. The largest place in this number is the ones place. One is larger than a tenth, so 1.29 is larger. Let's look at a real world comparison example. So let me read this to you. A solar collector is a piece of equipment that collects sunlight. That sunlight is then used to heat a piece of metal, which heats a liquid. The heated liquid can be used in the home to provide hot water. This is an example of using the sun's renewable electromagnetic waves to heat water. Heating water this way can help prevent pollution because this technology does not rely on fossil fuels, which are pollutants. Often, water is heated by fossil fuels, and those fossil fuels emit harmful gases when the fossil fuel is burned. Okay, now let's assume that your family is in southern Arizona. You have a cousin's family in southern California and another cousin's family in southern New Mexico. They have all decided to go totally green for making the family's hot water. Your family and the other two families only use the renewable sunlight to make hot water. Your family has a solar collector which heats 52.5 gallons of water per day. Your cousin's family in California has a solar collector that heats 51.5 gallons of water per day. And your cousin's family in New Mexico has a solar collector that heats 52.55 gallons of water per day. Whose solar collector is heating the most water per day using this solar collector technology, which is a pollution-free technology? Explain your answer. Okay, so you or your family, let's see, solar collector makes 52.5 gallons per day, and your cousin's family in California makes, let's see here, 51.5 gallons per day. And then your cousin's family in New Mexico, this family makes 52.55 gallons a day. And we want to determine who's making the most hot water. Okay, so let's go ahead and add some leading zeros to these two numbers so that all the numbers have the same number of digits. So we're going to put a 0 here. I mean, that's a trailing 0. We're going to put trailing zeros. And then put a 0 here. And now let's start our comparison. The largest digit or the largest place in each number is the tens place. Because each number has a 5 in the tens place, we can't make a determination as to which number is larger. We have to go to the next place, which is the ones place. Now, this number has a 2 in the ones place. This number has a 1 in the ones place. So that means that we can eliminate this number here because it has a 1 in the ones place. Now, we're left with this number and this number. Because they both have a 2 in the ones place, we have to go to the tenths place. This number has a 5 in the tenths place, and this one has a 5. So we got to go to the next smallest place. We got to go to the hundredths place. This number has a 0 in the hundredths place, and this one has a 5. So this number here is the largest. So your cousin in New Mexico, their family is generating the most hot water per day using the renewable energy or the renewable technology known as solar collectors. Here's an application of place value. So what we have here is a type of power meter used to display how much electrical energy your home has used. The number 448 is shown here. So this is the number of kilowatt hours of electricity used. Each place value is labeled in this picture. We got the ones place, the tens place, the hundreds place, the thousands place, 10,000 place, and the 100,000 place. To be honest with you, this meter indicates energy, not power. It indicates how much energy you have used, not how much power you have used. Now, you should be able to read this type of meter, but when you go to read this type of meter, it is not going to label the ones place, the tens place, the hundreds place, the thousands place, the 10,000 place, and the 100,000 place. You, as the reader of the meter, have to be able to do that. So because you now know about places and place worth, if we didn't have these labels or these places written above these numbers, you could now read this as 448. Now, summary. Place value is the value of a digit based on the digit's location in a number. Each place in a number differs from other places in the number by a power of 10. Moving one location to the right within a number is the same as dividing by 10. Moving one location to the left in a number is the same as multiplying by 10. Numbers can be written in standard form or expanded form. Leading zeros and trailing zeros in a number just serve as placeholders. Here are some questions and practice problems. Now, this link right here, www.ixl.com, has great fifth grade math activities and problems. So if you want additional practice, please visit this link and go to math on the fifth grade, because this link has, I think, problems and exercises for grades K through 12.